welcome back to Comparing Distributions in Chapter 4. In the last section and the last part of Chapter 4, we looked at comparing histograms and comparing stem plots. In this lesson, we're going to take a look at box plots and how to compare those. We know that histograms and stem and leaf plots are a great way to look at a small number of distributions, but it often becomes very difficult to see patterns by comparing like 12 histograms together or 12 stem and leaf plots. So what we can use instead is box plots because they kind of ingeniously show all their information in just one dimension. So you can line them up side by side to compare many groups. We were talking about average wind speed in the last part. So we're going to take that same topic here and take a look at the box plots for the average wind speed for an entire year. Okay, when we do that, we can see a couple things, like a couple patterns that are going on. So if you could, pause the video and write down some things that you notice about the trend here of the box plots when we're comparing them. So one thing that you should notice is that they tend to decrease in the summer. We can see that here, right, in the winter, and then the wind speeds die down and then they pick up again. So that's something important, right? The months where the wind speeds are strongest and most variable is actually October through March. And you can tell because the box plots are longer, right? So there's more variability, meaning the wind speeds tend to change more often during those time frames. Okay, so that's something that we would want to write down. Okay, you can pause the video again and read the check your understanding problem and then try to work it out. When you're ready, you can unpause and we can talk about it. Roller coaster riders want a coaster that goes fast. There are two main types of roller coasters, those with hidden tracks and those with steel tracks. Do they typically run at different speeds? Here are the box plots. Okay, so we're going to compare the speeds of the wood and the steel roller coasters. All right. So when we're comparing, we want to talk about like shape if we can, center, spread. And one of the things that I notice right away is that the median for the wood roller coasters is a bit higher, like slightly higher than the median for the steel coasters. Okay, but overall, the typical speeds are about the same. They're about 50 miles per hour, right? A little bit over maybe. The speeds for the steel coasters vary much more, as we can see. And that's very easy to see here. And they include higher and lower outliers, which are indicated by those dots, okay, the circles. And then this one here is actually a really extreme outlier, okay? And you know, there's some roller coaster out there in the world, a steel roller coaster, where, you know, it reaches that speed there. So that's really fast. I believe it might even be in the Middle East somewhere. And I don't remember the name of it, but I know you have to wear goggles when you're on that coaster. So we can say something like the median speed for coasters, for wood coasters rather, may be slightly higher than steel coasters. Not by much though, right? But overall, their typical speeds are about the same. around 50 miles per hour. Okay. And something else that's important to note is that the speeds for the steel track vary much more and include both higher and lower outliers. Okay, here's another example. This time we're going to take the steel and wood roller coaster data, and we're going to use our TI-84 graphing calculators to make comparative box plots of the roller coaster's drop heights this time. That's the height of the initial drop at the beginning of the roller coaster ride. And these drop heights are given in feet, okay? So here we have a comparison of the box plots for the roller coaster speed. Now we're looking at drop height, okay? So to do that, we're going to go into our graphing calculator, and I'm going to use my app. And the first thing I want to do is clear whatever's on there. And I have two lists of numbers I need to enter, right? So the first list I'm going to go to stat and then enter. And you might have some numbers in there already, right? So you can just scroll up on top of L1 and click clear, and then that will clear that column. And I'm going to type in the steel coasters there. And you just want to remember which is which. So steel is going in L1. Okay, I think I got all of them. Now I want to go hit the right arrow to go to L2, and here I'm going to enter the wood coaster drop heights. Okay, and we should end up in the same row, which I did. If you don't, when you try to do a graph, it's going to come up. It'll say like dim mismatch error. That just means, the calculator might be confused because there should be one, data point that corresponds to another one. Now, that's not necessarily the case when we're making two different box plots, because it could be two separate pieces of data and they don't have to have the same number. Okay, but just be aware in the future when you're trying to graph things that the calculator sometimes gets confused when there's not the same number of numbers in each column. Okay, so that's why we're going to kind of graph the box plots separately, and they'll show up together though so that we can compare them. So to do that, I'm going to go to turn my plot on. So I want to hit second, y equals, and you just want to make sure your plot is turned on. Okay, so I'm going to hit on. And then the color depends on you. I want to do box plots. So I'm going to choose my first box plot. And I'm going to keep the mark just as those little squares. And my list is an L1. Okay, so that's good. Now I want to go to my second plot. And I want to turn this one on. Okay, and I want to maybe use a different color, and I want to use my box plot, and I'm going to keep the mark the same. And this time it's an L2, so I need to change that, and to change it, you're going to click the blue button and then number 2, and then enter. Now to graph this, I'm going to hit zoom 9, which is zoom stat. Okay, so zoom 9. And then there's your box plot. Okay, my window might be off, and you should be able to change it. Like right now, I can't really see much of the blue. It's kind of distorted, right? So you can go into the window and play around with it. Maybe I want it to go from like, I don't know, negative 10 to 10. Okay, we can do something like that. So the y's I'm going to change, or maybe even -1. So -1 and then 10 and then zoom 9. Okay, now you can see it much better. Okay, and now we can compare them. So, something that I notice is that the steel coasters, again, had more variable drop heights, right? In addition to the variability we found in speed. So maybe that's why the speed is variable, because the heights are variable. Maybe steel coasters are higher in general, okay? Which it appears they are. So looking at the box plots, I can see that, steel coasters on average are higher in drop height than the wooden coasters are, okay? So that would be something to discuss, and I can see that the median drop height for the steel coasters, which is the blue on my screen, is a lot higher than the median drop height for wooden roller coasters. And maybe engineering wise, it can be that way. Okay, maybe the wooden coasters aren't as good when the drop height's higher. Okay, I'm not an engineer, so I don't know. But those are some important things that I would notice, as I'm looking at these box plots. Okay. So we may at times have to encounter some outliers. And there's a few days, if we go back to the average wind speed by month, there's a few days that could be nominated as possible outliers, right? So if I go back and look here, we can easily see that we have some outliers for each of these, okay? And what's interesting about that is when we lump all of those box plots together, though, which I think there is a graph for that, if I remember correctly, it's not really showing any outliers, right? Because, sometimes outliers when lumped with the rest of the data aren't really outliers. But when you look at each month individually, there may be wind speeds that just stand out among the rest of the others, okay? So cases that stand out and deserve attention could be outliers. They don't necessarily have to be. So an outlier is a value that doesn't fit in with the rest of the data, okay? And one of the great things about box plots is that they provide a general rule of thumb to highlight any unusual cases, but really they're just guides, okay? We can't really say by looking at a box plot that we have an outlier. It may be an outlier if it's standing away from the rest of the data, but it might not be. There's a way to calculate and find out. So to do that, we're going to find the interquartile range, the IQR, okay? Then we're going to multiply our IQR by 1.5, and we're going to find the fences, okay? And the fences are found when we take our first quartile and subtract the value we found here, and you look for any values that are less than that. If there's any values less than the fence, then those would be outliers. We're going to do the same thing for the next part, except we're going to add that value we found to our third quartile, and we're going to look for any values greater than that. That would tell us also that there are outliers. There's two things you should never do with an outlier, though. Leave the outlier in place and proceed like, everything's okay. And also omit an outlier from your analysis without comment. Now, certainly if the outlier is a mistake, like let's say someone typed data incorrectly and we, got an outlier in our graph, then obviously that's easy to mention that point was an error, and then you would delete it and recalculate. But if there is an outlier, you don't want to disregard it. A lot of times the outliers are the most interesting things that are in our data set, and they lead us to other information, okay? So let's practice really quick on how to find an outlier for sure. So we have this box plot, and it shows the fuel economy ratings for 67 subcompact cars. Some of the summary statistics are also provided. Okay, we want to know, are there any outliers? Now, my guess is this is an outlier, okay? And maybe this one's not. So there's a way to check if we're unsure. So we have our summary statistics here, which is everything we need. Remember, you can get that from your calculator. Once you enter in a list of numbers, you can go, and I'll show you here. So we have our list of numbers that we just used, right? Under stat. Let's say, oh, here's an ad, which will close here shortly. Let's say I want to find the summary statistics for my L1 list. All you have to do is go to stat and then hit the right arrow over to calc and hit number 1. And it's going to ask you, okay, where's your list? My list that I care about is an L1. And then hit enter. There's my summary statistics. So it's giving me my sample average, which is 147.9, right? That would be the average drop height for the steel coasters. And then I also have my sample standard deviation, 70.4, my population standard deviation, 67.4. Those are large standard deviations. And again, that's shown because there's a lot of variability in drop heights for steel coasters. And then I have my 5-number summary. Okay, so you have all the summary statistics to be able to determine information about those coasters and then about the if there's any outliers. So to figure out if there's any outliers here for these compact cars, the first step is I'm going to find the IQR, the interquartile range. Remember, all you have to do is take your Q3 and subtract your Q1. So when I do that, I get 5. Okay. Second step is to multiply that number by 1.5, and that gives me 7.5. And then the last step, pretty much, is to take your Q1, which is 20, and we're going to subtract 7.5. So that gives me 12.5, okay? That's your fence. You're going to look to see, are there any numbers that are smaller than 12.5? Well, the smallest number we have is the min, 14. So there's no numbers smaller than 12.5. So there's no outliers on this side, okay? But now I need to do Q3, and I need to add that number. So I get 32.5. Are there any numbers bigger than 32.5, which is where my other fence is? There sure is. If you look at the max, it's 112. So that tells me that that definitely is an outlier. Okay, because it's bigger than your fence. Okay. When we have data measured over time, sometimes it's a good idea to look for patterns. And, a problem that lends itself to that was the average wind speed, right? By plotting the data in time order, and when we do that, we get this display, as you can see here. It's called a time plot. So it's the average wind speed, and it's plotted in order over time, and it's over 1 year here. Okay, so what's something that you notice about it? Well, again, you can kind of see, as we saw in the box plots, you can see a little time where the wind speed was a little calmer, right? Starting around maybe the summer months. So that would be verified in our box plots that we looked at. The wind also seems to become more variable and stronger during the early and late parts of the year, which we also saw in the box plots. You can see how there's more scatter here and over here. So the earlier and later parts of the year, there's more variability. I mean, in the wintertime, the wind speeds can become more variable. And then also, in the fall, the wind speeds, like a blustery day, the fall can become, have more variable wind speeds as well. So here we can say that there appears to be a calm period around the summer and we always want to talk about variability. The wind becomes more variable and stronger during the early and later parts of the year. So I do want to caution everybody to please make sure you don't look too far into the future when you have a time plot, because things can change, right? The climate can change based on the location, and the seasons, etc. So it's always difficult to kind of predict what's going on beyond what we can see. For instance, it would be a mistake to go, well, it's decreasing, it increases, and then it's going to decrease again. We don't know that unless we look at the data. Statistical models can often tempt us to think beyond the data, but it can be dangerous to do so. And that's something we're going to look at when we get to chapter 7, and linear regression. So I hope you've enjoyed the video. I hope it's been helpful. If you have any questions, please reach out to me, and have a great rest of your day.